stuff's too easy for you. So.
Right. So I don't know if anyone is coming into the Google Plus Hangout.
I'm here.
You here?
Yep. Can you hear me okay?
Are you from India? Where are you from?
在台北。
台北. Oh, hey, 你们好。
你好，大家好。
Hey, Kevin speaks Mandarin too.
非常好，可是我们不可以听他们说，因为一点远。He's a little far from the microphone. Actually, he's quite far from the microphone.
Okay, I'll move up and I'll speak.
Okay, all right. So yeah, come out here.
Join the green podium.
So we're gonna start off. Yeah, your side. So,
okay, so we just
go to that. Go read that. Go read that.
Okay.
So don't get confused.
Yeah, so we've got a list of things we're going to run through today. State of web development as it is just now. Things like code injection, sanitizing inputs, some basic things you should know. Some details about cross-site scripting, request forgery, sessions and cookies. Dealing with passwords, hashes, some basic cryptography. It's good for the crowd here, maybe quite simple stuff. And I'm not sure we've got network security.
We have 2 slides.
With 2 slides of network security. Okay, so so give us some feedback. Let us know if you want us to go faster or slower. Focus.
If let me send here. So
sure.
The microphone.
Yeah. Okay. So do you want to take this one?
Quick question. Is this? Can we share it? Can we find this on Google Docs?
You will be able to find this on Google Docs after the talk.
Okay.
Okay, and just keep going. Yeah.
Yep.
Yeah. Feel free to ask us questions.
Okay.
During the talk.
So common threats, things that you're dealing with. Worms not making attacks. Very common problem. Very easy to deal with, keeping up to date with your software, but that's one of the most likely things you'll get hit with, and it basically just comes down to laziness. Targeted hacking, very hard to deal with, but you're very unlikely to come across it unless your company's doing something that's particularly making it visible. Malware and end users' machines seems very common these days. I think a lot of recent big cases seem to be coming from that people's machines are getting compromised. Most is only going to affect end user data. It's not going to get you into the core of your system, but can be a launch point to get you deeper into things. Internal threats we're not focusing on. If you're dealing in corporate environments, your biggest problem is mostly people in your company doing something you don't want them to do, and that's most of what security is. But I think with the audience we've got here, we're more looking at our own web products online and dealing with consumers or dealing with end users. So we're not focusing on that. And then information leakage, which again we're not really covering. Dealing with sort of permissions models between users. All sites are sharing more data these days. And, chances are you're going to make a mistake and share something you shouldn't. So probably a bigger problem now. Oh, I need to go back to this. Okay.
Yeah.
Okay.
So there are a number of common threat categories, some of which you might have already heard of. So if you're there are simpler kinds of attacks. Most common ones is defacement, meaning if you've done something evil and Anonymous caught you, they will hack your website, change your website to put that guy's face on your front page. Right? That's a Viva Vendetta. That's a symbol. Another type of attack is infiltration. So basically, what that means is that has a little bit to do with data theft and loss too. So basically, someone can inject code into your application, right, and just scan through the database and grab all the data out from it. Denial surfers is not something that we application programmers have to worry too much because there's very little we can do. It really has to do with scaling, so that has something to do with system deployment and like how you scale up your website And if you're in the cloud, I mean, Amazon is going to deal with that somewhat, but not entirely. Phishing, it's another very common type of attacks. Usually happens with shopping sites or banking sites, right? So some malicious attacker will send out spam emails to lots of people with a site that seemingly looks like HSBC or Citibank or whatever, but it's actually coming from a different domain from the official bank site. They will typically ask you to input your username, password, just like you would expect your banking site to do. And if you're not careful, you could enter your real banking credentials to a fake site. That's really, really bad. There's another type of attack called pharming, aka DNS spoofing or cache poisoning. What that means, basically it's on network security. It has to do with network security. So basically what it does is somewhere whoever controls the DNS will intercept your request, your DNS lookup, right? And then give back a completely different site that points to a completely different IP from the actual IP that you're trying to have the DNS resolve for you. That is not something that we can do much about. Same thing for DNS hijacking. So there are a set of common security best practices. The most basic one is called principle of least privilege. That has to do with your application and the OS that you deploy your application to. In terms of your application, you really have to, when you design your application, you really have to define what privileges users have to access different parts of your websites. For example, right, if you are not logged in, you are not allowed to see your profile or anyone else's profile information. The password, the email, the credit card information, you cannot see them. So that's one thing. In terms of the OS that you deploy to, basically you just have to ensure that the process, the web process that you're running, is not running on root. It has no write access to anything else other than its own user. So usually people will deploy a web process using a www user and www user group, and they only have access to certain folders on the system. You have to, another thing is database too. You have to have a separate database account, a separate privilege for each application, so on and so forth. Defense in depth, so basically that means you have to put many, many layers on of security to secure your website. So in case one layer goes down, you still have another layer to contain whatever leakage happened from the first break-in. So basically, there are 4 goals that you have to do when you're trying to secure your application. The first, you have to prevent it from happening. So you audit your code. Detect, in case something happens, you have to know that it is happening. Contain, when you know it's something that's happening, you have to limit the damage. Okay? And recover. When you're done limiting the damage, kicking all the hackers out, you have to recover whatever damage they have done. So that's how you secure your application. Identify and harden your weakest link. Usually that's people, right? Just teach them basic things, like don't just click on any links from the email, right? Always check the domain name, the URL is actually the URL that you want to go to. Right? Don't put any password information. Just don't type any password. Don't sign on to anything that you don't trust. And simplicity. The simpler your system is, the easier to audit and harden. So We're gonna go to web app architecture overview.
Right, let's spin through these. So
Yeah.
I've got a couple of slides to get through here, but just changes in web architecture over the years. Security is getting harder, or at least it seems it's getting harder. I certainly think so. I think that's true. We've got a lot more data than we did before. We're trying to work faster. We're being more dynamic. We need to get results out. There's more commercial pressure to be quick. We're now dealing with things like DevOps. Everyone here know what DevOps is? You heard the term before? Hands up if you've heard DevOps before. 3, 4? DevOps, yeah. So there used to be a split between systems teams and developers. And the systems teams are the ones that manage the production systems. Developers who make the code and hand it over to systems. Now that's very much becoming the application developers manage the application in production. And there's differences all over with kind of how that's changing. The upshot of that is that developers are handling a lot more of what the systems was used to do with keeping with package revisions. We'll get on to that. In the past, we used to see more things like buffer overflows. There's different types of attacks that we have now, and we're now doing more things like cross-site scripting, code injection. Just different types of challenges that we have. And your number of platforms is now huge. When you make a web application, if you're doing the Unix application in the past, you get a few different vendors, a few different platforms, so Windows. Now you're doing web applications, and it's just an incredible amount of platforms to deal with. So that's another challenge that you've got on there. So, quick view to web applications, circa early 2000s. You've got Apache, maybe CGI. It's not really a web application, it's something pretty crude. Things you're probably caring about there, it's a pretty basic web application. You're probably caring, is your Apache server up to date? Is there a buffer overflow in the kernel that someone could exploit with some network code? Keeping your firewall up to date. Applications were simpler back then. It's different state focus than what we've got now. Moving to mid-2000s, web applications are getting more mature. People are using frameworks more and more. Sites are getting bigger. And this is looking at someone that's just starting up. They're going to start with a lot of this to begin with. So I don't know what people were using, say, mid-2000s. Does anyone was doing Python back then? I was working with Zope at the time.
2007. I was using Turbo Gear.
Turbo Gears. Anyone else, anything they were using mid-2000s? What were you running back then? Did you have a framework or something you used, or? Okay, so frameworks are always just starting to come out from Python. There was other things in Java, and there's PHP as well. But generally, your application code is now starting to grow. You've got packages there for your kernel, your Apache, and everything else. You've now also got your application framework packages, and you're having to manage those, and that's beginning to grow. And that's the application developer that's doing that part. So yeah, more complex web framework. You're doing some AJAX. You're doing a lot more dynamic stuff going on there, and your JavaScript's getting a bit bigger. Here's what we've got now. You've got a lot more stuff going on. You've got web application services at the back end. You've maybe got search services on there. You've got NoSQL databases. You've got SQL databases. You've got an incredible amount of packages for your application level. You've got packages for your JavaScript. You've got jQuery, you've got Backbone, you've got Handlebars, you've got all these different things that are in there. You've probably got multiple versions of jQuery, whether you like it or not, because some package you're using depends on some old version, and you need to mix them. You're possibly using like a RESTful API, so you're actually accessing objects directly or more directly than you did before. Does anyone here use some kind of thing? Who here uses Backbone? 2 people. Anyone else use something with Backbone, or do you know what Backbone is? You've got something similar. Okay. So you'd probably have that talking, and you'd maybe have a layer that exposes some of your objects or exposes more parts of your system. So there's certainly a lot more surfaces on there that you're talking to. And there's also some external web services. You're maybe actually also communicating with Facebook, some plugins. It does post message. You've got all these different places are interacting. So yeah, effectively what I said. All of that JavaScript code you've got on the left there, that's also public. In the past, the code you wrote yourself was on your own server, people didn't see it. And I know it doesn't matter for open source, but there's certainly more things out there. So that's a lot bigger than it was before, and it's all in JavaScript. We're going to go and talk about code injection in JavaScript and how that matters. And you've also got all these data sources here. And you can treat some of them as being trusted if you want, the stuff that's coming from the back-end server, but in reality, especially if you're starting to use things like Backbone and you're using the RESTful API, there's a lot of possibilities of people putting data in there that can be used to exploit your system. Either a username, sticking some HTML into that, or so on. Packages and config management. So I'll just get back to that quickly. So you've got lots of third-party code in there. You've got a lot of dependencies. I worked on a project recently that had 90 packages on the application level. That's just inside the Python packages. And then you've got maybe 15 packages in JavaScript there. So there's a lot of different things going on. And your expectation now is people are expecting rollouts to be fast. You're expecting continuous deployment, or the amount of engineering that's going on there to actually get things rolled out is difficult. So dealing with complexity, and the basic things you can be doing, using packaging systems, obviously. Asset management for JavaScript. There is some package management now appearing for JavaScript as well, which is crazy, but that's what's going to happen. Using only trusted sources, making sure you're actually pulling these things, and you're not just pulling something off the internet and running it. At least take something from PyPy or somewhere that you've got a little bit more trusted. If something's malicious there, someone will have seen it. If you're doing 90 packages, there's no way you're auditing all that code. So there's always a risk that someone's going to put something malicious in there. For packages you don't need, don't include them. Try not to get to 90 packages. That's just a bit nuts.
Yeah, if you're just using one function from a package with 30,000 modules, then if it's open source, the best thing to do is just go to the source code, copy and paste that code, paste it into your own code base instead of requiring that library.
When you're doing this stuff, make sure you do keep an audit trail. And if you're pulling things, I've seen lots of stuff where people have made virtual env. Who uses virtual env? Okay, there's a couple of them. They list package names, but they don't list versions. And when they deploy the thing, it pulls in the latest version, or the latest version that they pulled out. You have no knowledge then of if a vulnerability appeared in a third-party package, when that started, and how much your data is compromised. So make sure you're trying to keep an audit trail of stuff, and keeping up to date with security releases, which is difficult. So code execution security flaws. This should be basic stuff to most people. Hands up here, everyone that knows SQL injection. SQL injection? You know what I'm talking about? Anyone else? Who doesn't know SQL injection?
You haven't heard of SQL injection.
Okay, that's no one.
So
yeah, just spin through it. So everyone knows, when SQL injections, you put arbitrary strings in SQL, someone can put something like this. I assume we've all seen the cartoon of little Bobby tables. Yeah. So someone in your SQL, they put a quote semicolon, and then they can write their own SQL statement and mess up your database. Dealing with it, use placeholders, use something that's going to escape it, and make sure that input, if it's unsafe, it will escape those characters for you. ORM and query builders, a lot of people are using these days. I'd be surprised if many people aren't. They'll deal with it for you for the most part, unless you're going to have to go and do and write your own SQL, which you do sometimes, but for the most part, you don't have to care about this. HTML injection. This is something that's analogous. It's very similar to SQL injection. It's also quite difficult. And if you looked back at all those JavaScript code that you've got there, any vulnerability in any of that JavaScript code that you're including can result in HTML injection. And then we'll go on to see why that's a problem, why that's bad. So you can see a basic example here, very similar to SQL injection. Someone's building HTML by hand in JavaScript and injecting it. And I'm sure you can imagine why this is bad. If somehow someone managed to make that string be this, then that image tag that you're building up there is no longer one image tag, it's 2 image tags. You could insert arbitrary HTML into this code here, and you can see that on the screen. So a more malicious example, if someone set their username to be something like this, and that username is loaded in the system and it's displayed on the page using that code, just very similar to what you've seen before, anyone that views that page, you're running the JavaScript there. You've taken control of that page, and you can then do whatever you want with the JavaScript on there. We'll look at cross-site scripting a bit later on and show why that's really dangerous. But basically, anyone can run arbitrary JavaScript in your code if you get something like that in there. So preventing the character escaping, quite straightforward. When you just anytime you're going to see these HTML entities, you can replace them out. There's different ways to do that. It can get a little hard to manage because you have to know what strings are already escaped, so you don't double escape them, what ones aren't escaped, which ones are trustworthy. Some functions are safe to use, some functions aren't. So if we look at jQuery, jQuery is a particular problem. Most of the methods in jQuery are not safe to pass user input to. And I'm sure if you audit quite a few libraries out there, especially once you're using your own code, you will find some place where someone's using jQuery.append, they're using the jQuery selector, and somehow user input's made it to that level. Now, maybe you don't care about this, but I'm sure you'll find it's in there, and the vulnerabilities stack up. If someone can do that, and they find they can change a username and you're not escaping that stuff somewhere else, then they can get JavaScript onto your page, and maybe from then they can project themselves further forward into your site and start taking the thing over. So there's a couple of safe methods to use there. Text, .atter, you can use those methods safely, but other ones, make sure you're sanitizing your input before you put them in there. HTML templates, probably even better than using jQuery, to actually use template language. And I kind of feel like a bit crazy that we've got template language in JavaScript now, but that's, you know, I didn't expect Node.js to exist, and now it does. And HTML templates are there as well. Make sure you use the escaped versions. Underscore, I've noticed the documentation for that. They commonly use the equals version in all their examples. Just make sure if you're using something like that you do the use the escaped version rather than just copy and pasting what's there. Cross-domain security. Okay, take back over there.
Right. So I'm going to talk about cross-domain security. So what I mean by cross-domain security is basically communication between two sites. You think of it that way. So most browsers these days implement a security policy called same origin policy. What that means is that any scripts will only have access to methods and attributes, which includes your DOM methods and attributes, from resources that came from the same origin. What same origin really consists of is a tuple of three things: same scheme, same domain, and same port. Okay? So if you look at the left-hand side, all of those things, all of those different resources came from the same origin. They all have the same scheme, which is HTTP, same domain, www.example.com, and the same port, which is by default 80. If you look at on the right-hand side, you see the first one uses HTTPS. That's a different scheme. That's not the same origin. Second one, has a different subdomain. So that's a different origin as well. Third one, different port. Fourth one, completely different domain. So we're going to start into going more in depth in one of the most common attack factors these days. So back in the days, in the early 2000s, I think someone started a project to keep track of common security vulnerabilities in web apps, not your desktop apps, web apps. In the early 2000s, the most common security flaw was buffer overflow. You rarely see them these days. In the mid-2000s, you're starting seeing a lot more SQL injections because obviously a lot of PHP programmers were writing SQL by hand. But they've learned their lessons. Now you have ORMs in PHP, and they're starting to pick that up. So in the late 2000s, cross-site scripting, cross-site request forgery are the main, starting to become a really big issue for web apps. And I'll explain what they are. So cross-site request forgery is basically, so back to the same origin policy. You remember this is basically a limitation on the code that's running inside your browser, right? Your script, say example.com, cannot call script, cannot basically open up an iframe to I know, google.com and scrape inside the iframe and find out what's in there, right? The reverse is not true. Where am I now? Okay, yeah, the reverse is not true. Anybody can still post to your server if you're not careful, because obviously you don't know what requests are coming in on the web server. So one of the possible scenarios is this. So let's say you are the webmaster of example.com. You have a resource called user profile that accepts post requests to modify email and passwords, right? So, and then on the right-hand side, you will have a phishing site, evilhacker.org. There's a form in there that posts to your URL, example.com/user-profile, and guess what is in there? It's got a password, right? So if this evilhacker.org is embedded inside some spam mail, right? Some unknowing, naive person gets it, opens that link up, click the form, input their email and password, bam, they've got you. So how do you prevent that from happening? There are multiple solutions. There's a naive solution is to require a user to enter the credentials before allowing them to access the personal info page. I mean, anybody who's implemented a form and you know how to verify passwords can do this. The disadvantage is it's pretty annoying, and it's not acceptable in the 2010s now because we are all about UX. So there's a second solution, which is use token. So what is a cross-site request forgery token? So before I get into that, I'll tell you how you should use it. Basically, if you're using a web app framework, chances are it already has that module or function provided for you. All you have to do is read the document and find out how to use it. Most of the time, what it really does is it generates a token of three things. Right? Your slides here. So this is it. So I'll briefly explain what's going on here in this math. So when you generate a token, it takes three things. The first is an application-specific key, which could be any password or random string that you generate that is specific to your application. So think of it as if you deploy on AWS, you probably know like you have a client ID or client secret or something like that. That's what it is. You have a secret, but hopefully it's distinct from your AWS secret, because in case your AWS servers go down, your application is not going to, or in case they penetrate your application and grab that secret, they're not going to be able to penetrate your AWS servers. You need a cookie that is unique to every browser session. That usually means your session ID. String delimiter, which could be anything that doesn't appear inside your cookie, or your third parameter, which is your location, which is just the path that you're willing to grant access to given that token. So what do you do with these three things? Well, you put them, well, you concatenate a cookie with the delimiter and the location, such that you can break them out afterwards. You initialize the MAC algorithm, and MAC is a message authentication code. The most commonly used one is HMAC. If you look into your favorite language, which hopefully is Python, there's a standard library called HMAC. Read the documents, find out how to use it. The way to use it is to initialize it with a key, which is K subscript MAC here. And then you update it with a message, which is the concatenation of C plus D plus L. And the third method that you call would be digest or hex digest, which will give you back a string. With that is your token. So that's a lot of words. Good thing is, most frameworks already do that for you, and I have to plug Blueberry Pie because I wrote it. But if you're using Django, there's a link there. Click it, find out what it does, how to use it. Flask, same thing. Don't invent your MAC implementation in case you have to do something that these frameworks don't take care of for you, or you're not using one of these frameworks. So when you have that token, you typically put it inside a hidden input element inside your form, so that when you submit that form, that token will go along with it. And that code below is how you break that token apart and find out, and then you get a cookie and a location. Right? With that cookie, you can find out the session, whether that's a valid session ID. But usually you don't check that. The only thing that you care about is your location. Right? So you break that cookie apart, you grab the location, then you grant access to it.
Hands up who already knew about cross-site request forgery. Who's already doing this at the moment, or knows that they're doing this?
Yeah.
You've not seen this before. You've not seen it. We're using okay. So.
Yeah. Okay. Good.
Because I'm sure a lot of people are using it. I'm just not sure who's aware.
Right. Not sure a lot of people know what it does. So okay. So we're gonna go to another attack vector, which is cross-site scripting. So here's an example. You are the webmaster of example.com. Your site is not secure. You have a resource called blocks, which accepts a query string that basically searches a bunch of blocks for a keyword, in this case, Apple, and some evil script that happened to be URL escaped. So what happens is, if you don't, so remember we talked about HTML injection before, right? So this is what happens if you don't escape your result. So suppose the result comes back as apple pie, and then you have that href anchor there, and then the script will actually get pasted directly into your result, and that script could be doing some really, really terrible things. So how do you prevent that from happening? In this case, always escape the URL on the server side, or unescape them. Or actually, I got that reversed. So escape a URL or HTML, escape them when you paste them into your HTML templates. Okay. If that parameter goes into an HTML attribute, such as href or source, you HTML and encode, you URL encode them. Okay. So JavaScript has two methods that allows you to do that. Go to Mozilla's developer network site and find out what they do. There's some things that you have to take care of. In Python, it's battery included, so you can just import URL lib and a bunch of methods that you can use. URL lib.quote, quote your query string. Basically, URL encodes them into percent encoding. By percent encoding, I mean something like that. You know, %3c, %3e, blah blah. Quote plus, that's a similar thing, except that it substitutes a plus sign instead of %20 for space. URL encode takes a dictionary of key value pairs and encodes them into a percent encoded URL query string. Path name to URL encodes a path name. Could be inside a URL or your OS path name into a form that should be displayed in an encoded URL. So so another thing to worry about is so these days people use JavaScript templates a lot, or rather dynamically render JavaScript in the HTML template. So suppose that in your Python code you have a dictionary that has a variable, var, right? And then you have a string that starts with quote and then brace, bracket, blah, blah, blah. Basically things that you close a backbone model constructor. So if you look at the Ginger.js template down there, now you could do something like that. You could just basically turn that dictionary directly into string and then paste it into your Ginger live template. And the result is on the right-hand side. What you really want to do, or rather what you don't want to do, is to have people execute code arbitrarily, or inject code that could be executed arbitrarily by the client. So how do you deal with that? Depends on where your data comes from. If it comes from a form field that has that you can filter out with regular expressions, you could use solution 2. But the thing is, it doesn't understand Unicode in 2.x. That's kind of useless. Or solution 1, which is you could just allow anything that's alphanumeric and anything in the CJK code block or whatever, and don't allow any weird symbols. Solution 3, make sure your code is encoded and decoded with a proper JSON serializer, because inside a JSON string, the spec mandates that you have to escape the double quote. Okay, that means you cannot break out of a string when you paste it into a JavaScript or JSON. So solution 4 is don't write this code in the first place, because I mean some people have CSS templates and JavaScript templates that is generated on the server. That's just it's very difficult to maintain. So session hijacking is also another attack factor that has a little bit to do with
We lost the sound on the Hangout.
Why is everything mute?
Oh, okay. Now we can hear. Thank you.
Okay, is that good?
Yes.
Okay. I don't know why it went mute.
Yes.
Kind of strange. But anyway, did you lose anything? Taiwan? Okay, I guess not. So, so basically, typically, your web framework deals with session one or two ways. The stupid way that was done in the early 2000s by some Java Surflet or Tomcat or whatever is to basically append your session ID on a query string, and then you bring it with you on every request and response. So basically what that means is that it spits out a URL to you with a question mark, J session ID dot some random number. And for every link you click on, that session ID is there too. So that's how you keep track of a session. That's rarely using. Most commonly it's done by a cookie that has a session ID and an expiry date for you. An expiry date is important. There's this thing called persistent cookies, meaning you could say, I want to log into this site for the next 2 weeks. That's what it's used for. In general, the shorter the time window, the better, because you basically are limiting the amount of exposure or possible exposure of that cookie to malicious attackers. So here's one way to hijack a session. Getting your session hijacked is very, very bad, because once you get the session, you could pretend to be that user and do lots of damage. You could change that user's email, password, credit card information, or grab it, rather. So this is first scenario. Evil hacker goes to www.xamarin.com, the session ID. The hacker sends Tom Cruise an email with the URL. Tom Cruise signs up to the Church of Flying Spaghetti Monster with that session. Evil hacker visits URL and change Tom Cruise's password, or rather just let it stay there and see what stupid thing Tom Cruise does, and sell it to Hollywood Insider or something. Scenario 2, same thing. Substitute session cookie. Well, should be reversed. Substitute session cookie with your query string. Scenario 3 is a very unlikely situation. It's an exploit of your browser vulnerability. Suppose same origin policy doesn't work in whatever browser you use. A hacker will be able to potentially set a cookie with a session ID that they know beforehand to any arbitrary domain, could be Google or whatever, and send you an email, you click that link, and boom. So how do you prevent that? So if you go on Wikipedia, they tell you many, many different ways to prevent session hijacking. Some say, don't put your session ID in a get a post request. Some say always ask for an email or password. Don't do any of that. Only do this, which is generate a different session ID for every request. That basically means you have to. So the way that you keep track of your session is to have a table of all the session IDs that you last generated. Okay, and when one person comes in with a request with one of those previous session ID, you immediately invalidate it, meaning wipe it from your database. And then in your response, you generate a new session ID for that user. Okay. CherryPy, Blueberry Pie does that by default. I don't know anything about Django or Flask. I tried Googling it. I couldn't find anything. I'm not about to look into that code. So if you know anything, it's time to speak up. Yes?
How do you deal with HTTP failures with that?
We cannot. No.
There's a session you go back, you don't need to reload the page if you go back. If you do reload the page, you pass a new session ID.
Yeah.
So that button should work, but if you've any HTTP requests fail, then you're logged out.
Yeah, then you're logged out.
Okay.
But if you are legitimate, then you could probably log back in again, right? You just want to lock out the hacker. Do you have anything on that?
Well, I'm just wondering if you did if you kept a couple of previous sessions and then I mean, this is getting into a discussion.
There's actually a scheme that deals with login session cookies, but it's rather complicated. I don't think it's implemented by anyone. I think Drupal is, but we don't use Drupal.
Yes, it would do, because I said that.
No, it won't. It just gives you a different session ID.
If I open a Gmail window and I type an email, and then I open it in another page, I wouldn't be able to send that email.
You'd have to have multiple sessions per user account, and you basically track those sessions separately. So session 1 gets invalidated and does its update, where session 2 hasn't been changed, and it's a separate chain. That would be interesting.
Yeah, I mean, this is one way to deal with it, but you have just illustrated that it actually presents a lot of problems. So lots of web frameworks actually don't do it. All they have to do is keep track of a giant session ID table. That's it. So this is debatable.
Interesting.
Yeah.
Okay.
So I'll give it to
Sure. I think we're going to do a little bit here about hashes, passwords, and crypto. And again, I think for most of you here, it's going to be quite straightforward stuff. Just stop me if you want to explain anything more, but I'll go quickly through these. So, straightforward thing, never store passwords in plain text in your server. There is no need to do this. If you do this and your server gets compromised, they probably use the same username and password on a different site. You need to then mail your entire user base and tell them to change your password. That's pretty embarrassing. You're probably still going to have to mail them anyway and tell them their email address has been compromised, but not their password. So hash the passwords. If you hash them, you convert a bit of text into a hash string. That same bit of text will always turn into the same hash string, but you cannot reverse that operation. So if someone finds that hash string 9E107, you can't get back to that original text, the quick brown fox. So it's a way to test for passwords and check them without exposing them. At the moment, SHA-256 seems to be recommended hashing algorithms. They always change over time, and old ones get compromised. SHA-1 and MD5 are kind of no longer recommended. For practical purposes, if you're using them, it doesn't mean you're necessarily vulnerable, but you're better off using 256 if you can. There's a couple of other new ones now. Salting. Hands up who doesn't know what salting is. Okay, so we've got one. When you actually encrypt that password, if you encrypt a quick brown fox, you encrypt that bit of text, it's going to turn into that result. What you do with salting is you add a couple of characters at the start, and then you hash that. And you store that hash and you store that salt. The reason you do that, if someone steals your password file, so let's say they get a database and they've got all encrypted passwords. If someone had the username of a password of let me in, then they're going to know what that turns into. And they're going to have a hard disk here with all those results. They do a quick comparison and they find anyone with let me in. If you've put some salt on there, there's no way they're going to have a hard disk with let me in plus this salt and then let me in plus this salt, and because there's so much different variations in salt, you couldn't store all those possibilities. That's kind of called a sort of rainbow table attack for doing stuff like this. So if you salt your password, it stops one kind of attack on breaking into them. It helps a lot if your accounts are broken. And then for end users, prevent people from using Joe accounts, which is the same username and password, or let me ins and other things. It's usually sensible, but you can't solve end users entirely, unfortunately. So next thing is random numbers. It's different amounts and different types of randomness. Genuine systems, you'll have random numbers that are secure and random numbers that are not very secure. Python's library, the random library, by default gives you kind of insecure numbers. If you've got one, someone can probably guess what the next one's going to be, because it's deterministic. If you're generating session IDs, if you're using things that are doing with cryptography, you need to be using secure random numbers. Your system generates random numbers. Your Linux kernel will generate random numbers from system noise, so it's things like network traffic, device drivers. It uses things that's going on in the system to generate random numbers. Some machines have a hardware random number generator as well that can generate very good quality random numbers. You might find you run out of random numbers. Has anyone ever had that problem? I've certainly had it.
I've seen people who have.
Anyone else who's run out of random numbers? So if you're using the secure random number, you're generating huge amounts of random numbers, you have this thing called the entropy pool, and that depletes because you've only got so much noise going on, and there's only so much stuff the system can generate, and that can run out, and your system will slow to a halt. Because every time you try and get a number, it blocks.
Yeah, so usually when that happens, if you have physical access to your machines, plug in a keyboard and just start typing randomly.
I was
for half an hour.
I was actually kind of looking at this. I was kind of curious what happens in CC2, and I found this, which I thought was quite interesting. This is the website Games by Dice. Oops, let me go back. People were complaining their random numbers were not random enough, so someone invented this, and it scans the dice that get rolled with a laser scanner, and it does 1.2 million dice rolls a day. I was quite amazed by this. Yeah, it's doing scanning of the dice and rolling them.
Scanning your dice.
So if you need good quality random numbers, there's a generator. Okay, next slide. Okay. Cryptography. So again, this is probably going to be quite basic. I'll do it quite quickly. Okay. Two main types of cryptography. There's asymmetric cryptography and symmetric cryptography. Who hasn't heard of asymmetric cryptography? Have you heard of public key cryptography?
Yeah. Same thing.
Public key cryptography? Yeah. Okay, right, so it's the same thing. So probably, everyone knows this stuff. So you've got two keys, one's private, one's public. You can use the private key to sign things. The public key you can use to encrypt data that only the private key can read. So you've got two different keys. You keep the private one, you give the public one out, and other people can send you stuff that's encrypted, or you can sign things to prove who you are. So, quick example, you give a key out, someone signs something, encrypts something, you can then decode it. And there's a signature. So you've got a document, you can prove that you've signed that because only you could possibly do this. It's all based around, pretty much everything's based around this algorithm called RSA. It involves some complex maths I at one point understood and I've now forgotten. But the idea is that your private key lets you do something that if you didn't have that data, you could work it out, but it's going to take you until the sun burns out before you could ever work that number out. So it's all to do with complexity and time. And it's the foundation of pretty much every bit of web security that's out there. And all your SSL, HTTPS. There's been lots of things over the years about the possibility that's been cracked, and it's a kind of interesting topic. And we're not going to get into it because it's far too complicated for this session. So, generate an SSL key. You can use OpenSSL. I'm not sure AES is recommended, but that's on there. So you can use command line tools. You can generate a private key, and you can then generate a public key from that as well. And you can use the same stuff for generating SSL certificates.
Usually, you only do that when you're trying to generate certificate requests for a SSL. When you're buying SSL.
If you're buying an SSL certificate, your vendor will have some instructions on their website. Just follow them. You don't have to care. It's straightforward. So, symmetric cryptography. The difference here is you've both got the same key. In some ways, it's a simpler form of cryptography. Does anyone know what a one-time pad is? Is this a new term to people? So the way that I'd usually take it describing it is you've got a document you want to convert. You've got another set of random data. You can combine these two and you output the resulted data. So each character in this data you want to convert, you take one character from this and you combine them. And you can only ever use this set of data once. It's considered the most secure kind of form of cryptography. So if you want to encrypt 1 meg of data, you have 1 meg of random data you then mix. Anyway, real symmetric algorithms don't need that much secure data. You can encrypt a lot of data for a small amount of sort of secure key. It's much faster than asymmetric cryptography. If you're doing something like SSL, as far as I know, it's all like HTTPS. It's all going to go over SSL. It uses symmetric encryption for the communication, but you have the handshake is done using the asymmetric cryptography. So you do the certificate that is signed, that shows who you are. You can use that to encrypt some data. You send over a key, and then you start talking with a symmetric cryptography. The most common thing you're probably going to see for this, the main algorithm for this one's called AES. I can't remember which one's just secure anymore. I know 128 used to be secure, but I have no idea if it is today or not.
AES it's recommended now. It's the fastest version of 3D.
Yeah, so every cryptography algorithm, check on Wikipedia for how it is today. And if you want to bet on it, you can go bet on it because it's probably changed tomorrow. So SSL certificates, probably everyone mostly knows about these. You apply to your certificate authority. They have a private key. They sign your certificate request and give you a certificate back. That then proves that you are who you are to some degree. The amount of proof that's in there only depends on how much checking they've done. You use this on your web server, you stick the certificate on there, you stick the private key on there, and you can then, your web servers then proves to people that you are Google.com, it proves that you are who you are. And then the data from that point on gets encrypted. If your private key gets compromised, that's a huge thing. I'm trying to think, but if your private key is stolen, historical data is probably also vulnerable. So even like past information that was recorded could be decrypted by someone with that key. I think that's right. SSL.
Private key, yeah, that's what it does.
Anyway.
Depends on what's in your request.
Yeah. So your browser's got a list of certificate authorities you can trust. There's a bunch of different vendors. You get Thought, Zero Trust, VeriSign, all these different companies. You've got different levels of SSL checks, level 1, 2, 3, I don't know if there's 4. And they do different validation on you. I think validation of level 1 just checks you on the domain name. Validation of level 2 probably checks your company name. You can go and check this online. If you're doing e-commerce, you should be using a higher level. And if you're doing e-commerce and you've got like transactions, your merchant account will probably require you to have a certain level of certificate, and they check your company exists and do some basic background checks on that there. But at the end of the day, the system's only as good as these checks are, and it's only as good as you trust these authorities. There was a couple of cases recently. There was a Dutch certificate authority. Yeah. And they're still around. They haven't disappeared, which is amazing. Their private key was compromised. Someone made a fake certificate for Google.com, and 300,000 people in Iran had their connections to Google.com broken into by the Iranian government, which is massive. That happened a couple of years ago, maybe last year?
Yeah,
last year. And I mean, when your certificate authority, the only thing you're actually doing is protecting a private key, and that's what you failed at doing. It's a little bit disturbing. So
the government was also using Diginatar for all of the public access to government.
No, so the Dutch government was using compromised CA.
Yeah.
issues.
So I think actually what happens is only certain certificates were revoked. There's systems and browsers to hand out sort of revoked lists and so on. But did you know are still there? I remember reading the bug list of this thing, and they were talking about it, and they didn't decide to remove DigiNotar, which I thought was amazing. So there you go.
Oh, that's one thing you could do though. If you're really paranoid, you could go into your Linux or Mac account, find out where in your system stores all the CA certs, remove the ones that you don't like. There are usually two that you really don't want to be in there. The Dutch one, what's it called again?
DigiNotar, yeah.
DigiNotar. And another one is the Chinese government's web CA certificate. Remove those two, definitely.
Okay. Well, if you're doing this, if you get certificates, do give them reasonable authority. And the risk is if you've bought from DigiNotar because they were cheap, you've now got a problem if that gets pulled. So, and your app stops working, it can no longer communicate with your server because it's been removed from the iPhone. So just, be sensible with stuff.
Wasn't there an artist CA that was compromised last year? Was it Komodo or something?
I know the name for, I don't know why though.
Yeah, I don't remember.
But there's been a couple recently,
Yeah.
but anyway. I think that's the end of everything. So,
yeah.
Got some resources on there. Everyone knows CVE, people don't know CVE. Hands up if you've not heard of CVE. Hands? No one has? Okay, it's a couple of people. There's some lists out there that you can sign up to for getting announcements about security things. I think there's another one called CERT, Commuter Emergency Response
CERT,
Team.
yeah.
There's Debian Security Announce, which is quite useful because they do cover a lot of software. CVE is another one that's out there.
Yeah.
They're not going to cover everything. You can't just rely on them for tracking your package vulnerabilities, but if it's something big and you're using it, and it's big enough that someone's probably going to write a worm that's going to exploit it, hopefully it's on there and you'll know about it. And if it was jQuery, then
yeah.
definitely
It's not complete, but it's fairly complete.
which are the ones web? These are two you've put
So
on.
yeah, Web Application Hackers Handbook. It's the textbook used by freshman Stanford computer science students when they're taking a web application security class. So it's actually quite useful, and if it's used by a first-year student, then it should be quite digestible. Founders of security, what every programmer needs to know is receptacle. So it's basically this book, which I think we stole a lot of material from this book.
I should note, Jimmy didn't write this book. He's not plugging his own book.
Right.
So
So yeah, we forgot about the disclaimer. So none of us are security experts. So take what our recommendation.
if your site is hacked tomorrow, don't sue us, please.
Yeah. So this book is written mostly by Neil Daswani. So I think he used to have a course on computer security at Stanford as well. Same origin policies, a link to Google's browser sec project, and a spec of what same origin policy does and should not do, how to get around it. Applied cryptography is another classic.
You're smiling at.
Yeah, classic textbook.
It's pretty full on. Like, if you're really crazy, go and read that book, but it's going to be hard going.
If you want to do a lot of math for the next year or 2 or 3 or 4 years, then read that book. It's written by Bruce Schneier, very...
He's described as the Chuck Norris of cryptography.
Something like that, yeah. The guy basically invents cryptography. So if you read his book, if you understand this book, then you're good to go. So questions, discussions, anything that you want to know? Taiwan? And India, are you still there?
Taiwan's here. Thank you very much.
I like this. When he talks, we get a picture of Taipei 101 showing up. It's good.
Yeah. Google Hangout is good. Do you have any questions?
Just
you want to know?
A lot of this started because Jimmy posted something about Ruby on Rails, and there was a Hacker News article about some guy, and it was pretty scary because it was like once they get into your infrastructure, then all kinds of things break. You guys know anything else about that or have any details?
Right. So what happened with Ruby on Rails was basically two variations of the same flaw, which is...
you have a JSON parser on by default.
Let me switch back to the slide there. It's did I go for it?
You went past it, yeah.
Oh, no, actually, I didn't.
Was it something or was it something else?
It's so basically what happened was it's a kind of code execution vulnerability. So Ruby on Rails for the longest time had a JSON parser or JSON serializer and deserializer called YAML, YAML. And YAML has the ability to read a specially formatted string that basically allows you to initialize any arbitrary object. So you could potentially, if you're using a PyYAML, for example, on the Python side, you could arbitrarily initialize
an object.
Yeah.
So it's
your user object, right? And then you can query into the database and fish out whatever you want, or just wipe the database.
So it's equivalent of Python pickle, basically. And they were taking any input from the outside world, and this was on by default. You could find a Ruby server, just send a string to it,
right.
Instantiate an object, and there was one object in particular that, if you loaded it up, you could have put some code in there that had just ran second on the constructor of the object.
Right. Right. So I think one of the things that we really want to get across is that when you are bringing in an external dependency, always know what it does. Okay. In the case of YAML, it's pretty well known that it will allow arbitrary code construction. Right. If you use it as a default JSON parser to parse user submitted data, which are not supposed to be trusted. Just should be untrusted by default, right? And things could happen very, very badly. So always think about what you put into your applications before you put them in.
Does Python have the same? Because like one mega flaw you get in PHP, they did actually have it in Ruby as well. It's registered global, so obviously you put it in.
The frameworks, I don't think they have registered globals. No, not the frameworks. There isn't a global request object, at least not in Django. But it depends on the framework you use. Okay. So Python's maybe not the thing to say. You probably have to say, does Django have it?
Yeah.
Django doesn't. I don't think it has.
No, I mean the threading models are different, right? Because if you have something global in PHP, it's really global.
Yeah.
Right. Well, each request is a separate thread.
But you certainly have a global variable. It's instantiated, and you read from it, and it's there. You have to deliberately read the request object.
Yeah. So that's it. Anything else that you wanted to know about?
Just one quick question.
Yeah.
In Django, we put the database username and password in the settings file, and that seems like you're just all you need. If it's a Django site, the first thing you do is you find the settings file, because that seems a little strange. Is that safe somehow? You guys know anything?
I would think that's the problem you might have been comparing it with. I mean, if you've got something with PHP and you've got that settings file in the file system, the thing you need to make sure is that that's not exposed. If you're coming through Django, you go through a dispatcher, there is normally no direct link to the file system, so you can't put an URL and get to the file system and get to that. I guess you do the problem, if someone does compromise that Django instance, then they get the password. I'm not sure how much you could do about that, though. I think it'd be very clunky to do much else. Is that what you mean by it, or?
Yeah, that's the vulnerability, the password exposure is there, and I think you described them saying that it's not that easy to get into the file system.
But I mean, anyone that's got access to that set of code there. I mean, the one thing you do need to make sure is if you're checking that stuff in to get and you're putting it somewhere, you shouldn't be putting that in to get with the password. Either you have a different repo for your config management, or you have your configs just not stored in Git at all, and you have a settings local file that's held elsewhere. And so your original settings file is just sort of blank, and your settings local fills that in. So there's some sensible things you should do on top of that as well.
Okay, that makes sense. Yeah. Cool, that's great.
Okay.
I have a question I was curious about. Has anyone ever here used Perl before?
Perl.
Perl?
Has anybody used Perl before?
Perl.
Yeah, P-E-R-L.
But no one using it these days. It's now regarded as like awful, and it is pretty awful. Perl's just hardware. Sorry? Over development. Well, it used to be popular, and people wrote big websites in Perl in the past, which is just crazy. And there was CPAN, which was a huge archive of packages, and it did some things that I think even current systems, like PyPy, doesn't do some of the things that CPAN did. But they did do some interesting engineering.
What are those things?
I'm trying to think. There's lots of stuff around unit testing, and it was all very. So they put a lot of engineering into the package stuff in CPAN. There were some things that were done nice in there. Maybe PyPy does too, so but I'm not sure what it is.
Oh, actually, I have some updates from the PyPy team, the Cheesop team, basically. So, so ever since that massive RubyGems.org security fiasco happened, and there were a lot of requests on the catalog SIG, stands for special interest groups. It's like something to copy from ECM. So basically, a lot of software, Python Software Foundation people are going to enable SSL on PyPy downloads and uploads by default sometime fairly soon. And there are a couple of pull requests on pip that basically enables SSL by default, and it will do certificates verification for you. So what that means is that in the future, if there's a package, okay, is that coming from Taiwan?
Yeah, it's coming from Taiwan.
Sorry, I'm muting.
Okay, so basically what happens in the future is that if you have a new package that you want to submit to PyPy, there are two things that you should do. First thing is that most people don't know about this, is that PyPy actually supports signing your package with GPG. And the second thing is that you should always sign it and submit it over SSL. If you have a package on PyPy now, they will ask you to basically renew your password, or rather just change your password, because they're going to wipe the database very soon. Don't know if you know that, but I think in January it was found out that wiki.python.org was potentially compromised, or was it compromised at all? I don't know. Was it wiped, or I don't even know. Yeah.
Yeah, they had to rebuild it.
Yeah. So so apparently that attack was possibly planted since July, and nobody found out. Right? Remember I talked about prevent, detect, contain, and recover, right? So they failed in every single category. They lost half a year of data. They couldn't prevent it. They couldn't contain it. They couldn't detect it. So this is what's going to happen, even to Python Software Foundation.
Who here somebody? This is not a limit. Who had a server compromised at some point? I know I have. It's happened. It's anyone else? Not disclosing a liability if you're yeah, okay. I was just curious about how people
Okay.
For my case, I was using an XVG.org. And then the guy who's been maintaining the software on it, that was an old version of Sun 4, which you hacked into. And I found the typewriter.
Can you hear us, Taiwan?
I think he's dropped now, he's gone off.
Have we? Oh, yeah. Okay.
There was some worm going around.
There's still another guy.
Server, and unfortunately, there's no patch out.
So, anybody on the other side of the planet has any scary story to share with us, like getting your server compromised?
The one that happened to us was because PHP is they managed to get the PHP file into a place and get executed and add just an eval into it. Well, an eval which they could put any script as a request parameter and just get eval from the system.
Okay.
So essentially they could do whatever.
Yeah, that's another good point that you just brought up. So apparently, PHP, JavaScript, and Python have this function called eval, which is very, very bad if you're not careful. What happens is, suppose you're getting smart, you want to have a form that asks for user-submitted data, and then you, instead of validating it, you just call eval and turn it into a string. Bad things can happen. Very bad things can happen. On the other side, on the JavaScript, you could also do the same thing, right? Suppose somebody inserted some string that could potentially result in a cross-site scripting attack. When you render it out, if you don't escape it or don't pass it through a JSON parser, you just call eval, things could blow up. PHP is similar, right? So I think a couple of other languages has this thing too. So be very, very careful if you think that you should use eval.
I had a quick question.
Yeah.
You know, I think I saw recently that Gmail now offers an option of going through HTTPS.
Yes.
And it seems to be a little heavier, but have you heard of this as one way to get around security, or kind of block some of the security problems?
I haven't heard of anything. Have you? No,
no, I know they defaulted to because
they have defaulted to HTTPS. Well, actually, I do have a story about Gmail to share.
I'm surprised more sites don't actually. It's not like I know it has computational load. The accelerated card you can do also.
Yeah, so number of sites have enabled SSL by default since the attack on Gmail a couple of years ago. Google, even if you do a Google search, chances are if you're logged in, it's SSL enabled. Facebook, Twitter, Gmail, obviously. I think does any Microsoft sites default to SSL? Like Hotmail and stuff. Yeah.
Microsoft spoke.
Yeah. Like Outlook.com or something. Does it use SSL by default? Outlook.com, does it use SSL by default?
I never use that.
Oh, okay.
Do you have an iPhone? No.
So, yeah. So actually about Gmail, I do have a kind of scary story to tell. So around 2008, I think I did something horrible to the Chinese government. I signed the OA Charter. If you don't know what that is, look it up. What that means is that I'm probably in the database and I'm officially a descendant. So I think right around the guy who wrote the OA Charter was arrested in China, within a day or two, my Gmail account was hacked. So when I logged in, Google basically said, hey, your account was accessed by some IP from China. And then immediately I have to change my password. Within a month, it got hacked again. This time, I don't know whether it's from Twitter. My Twitter account was hacked too. So, and then I had to change my Gmail password again and turn on SSL on everything and turn on two-factor authentication on every Google service. So I've been pretty paranoid ever since.
So is there a moral to the story? Is to not
The moral,
password or to not sign charge?
right, the moral of the story is that if you decide to be a descendant, always make sure that you don't share your passwords across services. That's it. So, yeah. There's some people are talking in the chat room. I haven't looked at it for like a year. What's that?
How do you know it was hacked? They changed the password?
Google detected it.
Oh, they told you that.
Yeah. Google told me that, hey, all of a sudden your account was accessed by some IP in China. I mean, you would think that they would know how to use Tor, but no, they had to access from China.
It's all from China.
So.
At the bottom of your email, you can check like last. Yes. A few years ago, I wrote this about something like state, and then I shared it. And then you said, well, there's something wrong in the system, and then Google comment statement about that. Yeah, and then log in from USA on the same time. And please make sure about the please take some action to verify our action.
Right.
There's sometimes some mishaps happen.
Right.
At this moment, I have everything to change the password and then set up a two-step verification. And then I say, I will not work this last time. I will not work anymore.
Okay.
Yes, because it's very insecure from what it's done.
Okay.
People really don't know how to protect this thing.
Okay. Yeah. So, so basically another thing that you should worry about is always work with the people that you trust. If you're sharing sensitive data, make sure that you are communicating. When you're sharing them, make sure you're communicating through secure channels, like a secure Dropbox account that only 2 of you know about, right? Secure Dropbox account. That's a that's a little asking too much, but yeah. Right. Or Mega, mega.co.nc. Right? Anything else?
Oh, you know, one other thing is a lot of this is talking about kind of the stuff on the web developer standpoint, but you know, small startups they write the code and the system admins, and
right. So
you know, detecting when something's wrong, that seems like a whole new world.
So yeah, so how do we detect? So mostly this talk was about preventing. Right?
Yeah, you see that can be very difficult. I mean, if it was something automated, which you say is probably your biggest thing, you probably notice when you start doing something like using your server to denial of service something else, which is a very, very common thing to happen. And that's how mine, you know, I get called up my colo provider. You're spewing out, you know, several hundred megabytes a second on your port. What are you doing? I'm not doing anything. And that tends to flag you up about it. If it's something that's on there and it's reading data and it's siphoning it away, it can be very difficult to spot that. There is intrusion detection systems, and they tend to more focus on actually you own the network, and you put it outside.
Anything simple that you know is good for like small kind of startups.
I think I can't think of any reasonable suggestions for that. I mean, it's a hard problem, and there's no magic answers to think for that. The main thing is that if you've got the audit trail on there, and you're keeping up to date, and you're doing the sensible things, then the only thing is damage limitation if it does happen. That's all I can really think of, unless anyone else is good.
Splunk.
Splunk, yeah.
Yeah, because that's the cool thing about that is you can monitor. If you just monitor the traffic, you would actually notice probably either if there's a spike or there's something on the post request.
Does Splunk do anomaly detection? So does it flag?
It won't flag you, but it will at least make you more aware of what your server is doing.
Yeah.
And the good thing about it is because it's really easy to search, you can go back through requests and start to narrow down the intrusions a lot quicker.
There's another one you might want to have a look at is there's a package called LogCheck, which I know it's in Debian. I'm not sure how much it spreads to other places, and it does look for some analysis in your logs, and anything that's unusual, it will send you an email of spurious log events, which is quite a good filter to get that kind of sent to you. Particularly pulls up things like pseudo alerts and stuff. Otherwise, maybe if you have some sort of basic graphings of your server, watch for unusual activity on that. Spikes are just unusual. Running netstat and looking for open connections that you're not expecting. There's another. What's the piece? There's a piece of software that checks for rootkits. There's a package out there that will check for rootkits, and that used to be well updated. I don't know if it is anymore. You run it, it scans for any unusual processes. It also does some heuristics and looks for things that are weird. You can use that. There's tripwires, and you can use your package database to compare the signatures of files and see if anything in the system's modified. But for a small startup, that's hard. And this is why I say it's difficult to think of things that you could necessarily do, but they used to be popular in the past as well. So tripwire and then checking package checksums might be.
Okay, cool.
Right. I think we're done for.
Yeah. Thank you, Taiwan.
Bye bye.
See you guys.